Welcome to my Kcse Mathematics Revision channel. I am Teacher Marita. Kindly subscribe my channel, watch and share. We are looking at Kcse Revision Mathematics Paper 1, and today we are looking at question 3 of Kcse Paper 1 2024 and also question 4. In question 3 of Kcse 2024, it is a questions of the question was from equations of a straight line. In equations of a straight line, of course, from form to work, you understand that you need some principles to understand for you to do this question. That is how to get the gradient of a line, a very, very important part. How to get the equation of a line when the equations are either in perpendicular or when the equations are parallel. You understand when the lines meet at x-axis, what is happening there? At y-axis, what is happening there? So if you understand all those principles, you will be able to do this question as well. So in question 3 of 2024 paper 1, there was this question where a straight line 1 whose equation is y is equals to p 2. The equation of that line is equals to p 2 minus 1 over 3x. This question here of line 1, it meets the y-axis at q. So you understand here at y-axis, you need to know what will happen there when the lines meet there. At x-axis, what will happen there? Then there is another line 2. There is another line 2 line which is perpendicular now to line 1. This line is perpendicular to line 1. At what point? At the point Q. You understand it there. When the lines are perpendicular, what are you supposed to understand? Perpendicular lines, where they meet, they make an angle of 90 degrees. Find the equation of line 2. Find the equation of line 2. We can call it this one L2. Find the equation of line 2 in which form? In the form of y is equals to p mx plus c. You get that equation in linear form. So to start with this one here, that we have these two lines here. So if we can have that line, line 1, we have this is line 1. Our line 1, the equation of this line is y is equivalent to p 2 minus 1 all over 3 of x. That is the equation of line 1. Then there is another line 2 which is now perpendicular to line 1. This line 2, when two lines are perpendicular, they make an angle of 90 degrees. So I can assume that this line, we have this line, the other line 2 here. So we have our line 2. This is L2. They meet at this is point Q here, and they make an angle of 90 degrees. When two lines are perpendicular, where they meet, there is an angle of 90 degrees. So there is a line 1 with an equation of y is equals to p 2 minus a third x. And then we have line 2 whereby it meets this line, it meets line 1 it meets line 1, this one here at line 1 at this point Q here. So we are supposed to find the equation of line 2 in linear form. Linear form, it means you get the equation in the form of y is equivalent to mx plus c, where c is the constant. M, of course, is where m and c are a constant, and of course x is the gradient of the line. So at x-axis, so you understand here, at y-axis, so we start with at y-axis, they meet at y-axis, so at y-axis here, the value of x is equals to 0. Understand that. At y-axis, the value of x is equals to 0. And at x-axis also, the value of y is equals to 0. But now we are talking of y-axis. So in our equation here, we are using y-axis where x is equals to 0. So if now the value of x is equals to 0, what are now the coordinates of q? If if y is equals to, if x is equals to 0, it means the value of y is equals to, from here we have 2 minus 1 over 3 into 0. Why into 0? Because the value of x at that point is equals to 0, and 1 over 3 times 0 is equals to 0. It means now the value of y is equivalent to b. The value of y is equals to 2. Meaning that the coordinates of point Q here at y-axis, y is x is equals to 0, and then we have y is equals to 2. These are the coordinates of this point Q. And then we need to get the gradient. We can call it gradient 1. So in our gradient 1, which is gradient m1, which is equals to p, from this equation here, y is equals to p, 2 minus a third x. The equation is already in linear form. If the equation is already in linear form, it means that now gradient 1 of line 1 is equals to p negative 1 over 3. The coefficient of x, when the equation in linear form, the coefficient of x becomes the gradient of that line. So gradient 1 of line 1 from the equation here is negative 1, negative 1, negative 1 over 3. There is one thing you need to understand, that when two lines are perpendicular, the product of their gradient is equivalent to negative 1. It means that gradient 1 times gradient 2, the answer is equals to be negative 1. Now that our gradient 1 is equals to be negative 1 over 3, we are expecting that our gradient 2, which is line 2, must be 3, such that m1, which is 1 over 3, so our m1 here, which is negative 1 over 3, times m2, we don't know this one here, is giving us a negative 1. So the answer must be negative 1. So if we can replace this one here by 3, we get that 3 by 3, so it's giving us 1. Therefore, our gradient 2 is equals to be 3. Then the point is here of this line Q, the coordinates at point Q is 0, then we have 2, and then we should have an imaginary coordinates. The imaginary coordinates of this line 2 is x and y. So having these 3, that is the gradient, which is equals to 3. Then we have the coordinates of this line Q, which is 0, 2. And then we have x and y. We can be able to get the equation of this line using some knowledge from form 2. To get the gradient of a line, we have change in y coordinates, then you divide it by change in x coordinates. So in this case here, we have our change in y coordinates. We are using these two coordinates here, where we have q, which is 0, 2, and another one, which is an imagination or imaginary coordinates, and that is x and y. So we have x minus, we have y minus 2. This is xy, xy, y minus 2. So we have y minus 2, change in y coordinates. You divide it by x minus 0. So we have x minus 0, change in x coordinates. And this one is giving us the gradient, and our gradient here is equals to p, is equals to p3. We can put this one over 1. Then we do 1 times y minus 2. We get y minus 2, which is equals to p, that is close multiplication. 3 times x minus 0. Of course, this one is giving us, we get that one as 3x. We need to get that equation in linear form. So in linear form, the condition we have to get that equation in linear form, it means now we remove this constant from here. Since here it is a negative, when it goes to the other side, crosses this equal signs, the sign will change from a negative to a positive. So in linear form, y is equals to 3x. This one on the other side, it becomes now positive 2. And this is the equation in the form y is equals to p, 3x plus 2. Correct? That is this question 4 of Kcse 2024, that's paper 1, where we had a circle of radius 3 centimeter, passes all the vertices. this circle, it passes all the vertices of a regular hexagon. The regular hexagon, the word hexagon here, it means that this polygon, it is a polygon with 6 sides. From the word hexa, hexa means 6, so we have hexagon, it means it is a polygon which has 6 sides. You can visit Form 2 work where you look at the properties of a polygon, the properties of polygons, and also the angles on polygons. You will be able to understand from Form 2 work. So after this circle, which passes all the vertices of a regular hexagon, so determine the area of the circle that lies outside the hexagon. So if we can have our circle here, so let me have that circle. This is a circle here, and remember this circle, it passes outside, so we have that this is a circle. This circle, it has a radius of 3 centimeters, and it passes all the vertices of a regular hexagon. So a regular hexagon, I have said it, there is an hexagon inside here. So if we can have one side of that hexagon like that, this is a one triangle. So we have one side, then we have 2, 3, this is 4, then we have 5 and 6, of course. So we have 1, 2, 3, 4, 5, 6. So it means that this one, it has 6 sides. So we can have those hexagon. This is an hexagon inside here. So that is it. So this is the circle which passes all the vertices of the hexagon. All the vertices, the vertices here, 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 on this side and this side. So we have an equal of 6 triangles inside this circle because of this hexagon. So this circle, if we can pick one, we have this is this part here. This is now the part. You can look at this part. You look here, this part is here, the parts here like this outside here. These are the area of the circle that lies outside the hexagon. So we are talking about these areas. The area here plus this one plus this one plus this one plus this one plus the area of this part here will give us the total area of the circle that lies outside the outside the hexagon. So how do you go through about this one? So the first step we are supposed to get, since this is 3 centimeters, this is 3 centimeters, this is 3 centimeters, as we have been told that it has a radius of 3 centimeters. So we need to get the angle substance at the center of this one triangle. So that is the exterior, the interior, it is an exterior angle. So you can call it an exterior angle here. So the exterior angle is normally given by us. So we can get that angle. So we can call it, we can call it the exterior angle, which is given by 360 all over n, where now n is the number of sides. So if n is the number of sides, and the number of sides, of course, we have 6, it means that now that exterior angle is 360. You divide it by 6, and that angle is equivalent to be 60 degrees. So we have the angle at this center is equivalent to be 60 degrees. So to get the area of the circle that lies outside the hexagon, you go through around 3 steps. 1, you get the area of the hexagon. So first we have area of hexagon. The area of hexagon, of course, which is given by half radius squared, then we have sin theta. That is the formula we can use there. Such that we take this one triangle, we can extract this one triangle here, but remember we have 6 of them. So the area of this hexagon now is a half times the radius is 3 squared times then we have sin theta, which is in this case 60 degrees, then times, remember this is for up to this part, it is the area of this one triangle. And how many triangles do we have there? The number of triangles we have 1, 2, 3, 4, 5, 6. So we can multiply this one by 6. So we multiply this one by 6, we can get that area of a triangle. If you can use you can use a calculator, you get that area of a triangle as 23.3827. So we have 23.38, then we have 27. This is centimeter square. That is step 1. Step 2, we are supposed to get now the area of a circle, the area of the whole of this circle here. The area of a circle, so area of a circle, the area of a circle, of course, which is given by pi radius squared, and this is the same as now 22 all over 7 times radius squared is, the radius is 3 squared, and that one is giving us 28.28. 28, so this one is equals to be 28.28, then we have 57, then we have centimeter square. So to get the area of a circle that lies outside the hexagon, this is the area. So you take the area of a circle minus the area of the hexagon. So the area of a whole circle, this one here, minus the area of the hexagon. So the area of a circle that lies outside. So area of circle, and this one is outside. You take 28, which is, this is 28.2857 centimeter square minus the minus 23.3827, and the whole of this one you will give. If you take this one minus this one, you can now get the area of a circle that lies outside the hexagon as 4 points. This is 4.903 centimeter. 3 centimeter square. So you get this is 3, then we have centimeters square. That is how you can get the area of a circle that lies outside the hexagon. First, from 3 work, you will be able to understand the area of a circle, the area of a segment, and of course the area of a triangle inside a circle. You will be able to understand it well. Don't forget to follow my channel, watch and share.